Hi, in this video, I'll show you how to graph a polynomial by using a table of sign. There's a key insight in doing this, and let me show you on the graph of this very high degree polynomial, y is equal to 2x to the 6th minus x to the 5th minus 11x to the 4th plus 5x cubed plus 13x squared minus 4x minus 4. And these are its zeros. The key insight is this: in between any two consecutive zeros, the sign of the function doesn't change. For example, in between these two zeros, all of the graph in there is of the same sign. In this case, it's all negative. I can look to the far left, and I see that here's the first zero. For the interval before that, the entire part of the graph is positive over there. In between any two consecutive zero, the graph is either all positive or it's all negative. So the question is, how do we know which is which? Is it all positive or is it all negative? We figure it out by picking a test x value in between and plug in to see if the function is positive or negative. For example, if we don't actually have the graph, but we do have the zeros like this, then we know, for example, that in between -2 and -1, in between x equals -2 and x equals -1, the graph must be either all positive or it must be all negative. It cannot switch signs in between them. So we're just going to pick a point in between, any point. So -1.5 sounds good. X equals -1.5. And we plug it into the formula for y. And we see what comes out. We find out that y is equal to -10.9375, which is a negative number. So we know that the graph is all positive in between there, and it would look something like this. And we're going to do that for every single one of these intervals. We're going to do that for the interval before the -2, the interval between -2 and -1, between -1 and -0.5, between -0.5 and +1, between +1 and 2, and for the interval after x equals 2. So to do it methodically without like messing up, we put it in a table. First, we put in all the zeros in numerical order from left to right, and we'll make sure we leave some space between them. We know that y is equal to 0 at these points. We'll check test points of x in each of these intervals. For example, we already checked x equals -1.5 here, and we got a negative number. It was -10.9 something. So we know that this entire interval in here is going to be negative. Now for the two extremes, the far left and the far right, if you know the rules of n behavior, then you can apply that. In this case, our function is y equals to 2x to the 6th minus x 5th minus 11x 4th plus 5x cubed plus 13x squared minus 4x minus 4. If you know the rules of n behavior, then you look at the degree of x, which is even, and the leading coefficient, which is positive, and it tells you that the n behavior of this function is similar to the n behavior of the function y equals x squared, which is positive on over both ends, positive here and positive there. I will be putting a link to a video regarding n behavior of polynomials in the description box. But if you don't know the rules of n behavior, just plug in a test value. So for example, over here, we could plug in, and usually people put the test value in parentheses so they don't get it mixed up with the value of the zeros. Before -2, let's check -3, and we end up with y is equal to something like 800. So it'll be positive. We already have this interval. So this next interval between x equals -1 and x equals -1/2, we can test something like -0.6. and plug it in, we get 0.745, which is a positive number. Between -1/2 and 1, we can test for the number 0. Always pick an easy number when you can. When you put in x equals 0, all of this is just 0. So you have -4, so that's negative. So far, you see that the graph alternates positive to negative, and then back to positive, and then back to negative. You may think that it always alternates positive and negative, but no, that's not true. It does not always alternate positive and negative all the time. As we will see right now by checking in between 1 and 2, a good test number here would be something like 1.5. Put in and we get -4.375. So it's negative again. And then on this end, I could test something like x equals 3. And that gives me y equals 560, and that's positive. We have the signs. We'll start sketching the graph according to these signs. Let's put all this information into the graph. The table of signs will help me draw the graph. For the interval of x less than -2, it says the graph is positive. So for the interval of x before -2, the graph is positive. So it looks something like this. The interval between between -2 and -1, the graph is negative. So it's something like this. The next interval is positive. So it's something like this. Next interval is negative. Next interval is still negative. So it's something like this. And the last interval is positive. So I just connect them together, and I have a graph like this. It crosses here, and in this part here, where the graph is negative on both sides, then I do a sort of like touchdown and take off again, sort of like an airplane landing and take off, except it upside down, landing and take off. And over here, it just crosses. So that's a rough sketch of the graph based on the table of signs. If I want to be more exact, I can calculate the y-intercept, which is equal to -4. Maybe I should draw the graph a little more like this. But in terms of the shape of the graph, this is pretty good. Now let me erase the whole thing and draw a cleaner looking graph without all the hairy stuff. Crossing, landing and takeoff, and crossing. The graph is something like this. Let's compare it with the real thing. Pretty good. Same shape. I miss how steep this is, but in terms of the general shape, it's pretty much identical. So that's how you draw the graph of a polynomial by using the table sign. Let's summarize. Number 1. Find the zeros. In the example I just did, we were just given the zeros. In an actual problem, sometimes you are just given the zeros, then just use it. But if you're not, then you actually have to find the zeros. Number 2, make a table of signs with the zeros in numerical order. Number 3, use end behavior. And I put it in parentheses because if you don't know it, you can just jump ahead to step 4. Use end behavior if you know the rules. As I mentioned before, I will be putting the link to a video on the end behavior in the description box. Number 4, pick a test value of x in between the zeros to determine positive or negative. And number 5, sketch a based on that info. If 2 positive intervals in a row or 2 negative intervals in a row, do a landing and takeoff. So you have one of those smooth bounce off of the x-axis. Well, that's it. That's how you sketch the graph of a polynomial. Hope that helps. Thanks for watching. Click subscribe for more contents, and bye.